Two of them open again. Okay, so today we're just going to do a couple questions all in, everything, okay? I'm going to speed it up a bit though, because these could be a bit arduous as notes that I'm not going to go through and do the entire derivative with you. I'll say this was the derivative, okay? And if anyone after class is like, man, I don't know how we'd even get that derivative, right, then we can talk. And second derivative and stuff like that, because we got to find that balance. Like, I know you want as much information as possible, but you know, the human being can only handle so many notes, right, before it's not even sinking in anyway. Okay, so here's all the things that are going to be expected for you on the unit exam. One question on the written response. Here's the equation, sketch the curve, okay? And you won't have to memorize, oh, what things to do. I'll ask you, what's the domain? Intercepts, symmetry, asymptotes, okay? So let's just quickly go through these. Now, when we're talking about domain, what are you looking for to be able to help you establish domain? What things restrict domain? Discontinuities, right? Usually rational functions or radical functions, because they would have restrictions, okay? So instead of looking for what everything it can be, sometimes it's easier to look for everything it can't, okay? So look for NPVs, i.e. variables in the denominators. Okay. Now intercepts, remember for y_int, make x equal 0, for x_int, y equals 0. Okay, symmetry, if f of negative x equals f of x, or if f of negative x equals negative f of x. Now, if f of negative x equals x f of x, okay, example would be like x squared, okay, which looks like this. Okay, this is called an even function. Okay, so it has symmetry about y-axis. Basically, if you reflected on the y-axis, you would get the same exact graph. Now, that's valuable because if I just gave you, and I gave you one like it in example in the last notes, but if I just gave you this part of all of the information, but then I said it's an even function, you would go, oh, then this must be the other part of the graph, okay? Now, if you have f of negative x equals negative f of x, this would be called, example would be x cubed, and it would look something like this. Okay, and this is an odd function, and that would be symmetry about the origin. Okay, in other words, if you rotate 180 degrees. Okay, so if you rotate it 180 degrees, you get the same graph, then it is an odd function. Okay, hopefully this is all review. Okay, your asymptotes. Your vertical asymptote is your NPVs. Now remember, sometimes it can be just a hole in the graph, not always an asymptote, but most of these, it's going to be an asymptote. Now, horizontal asymptote, we've talked about those a lot. Oh yeah, I guess for vertical asymptotes, make sure you're doing limit, right, as x approaches a from the left and the right to see if it's approaching infinity, negative infinity. So we'll put of f of x. And does that approach positive infinity or negative infinity? Right? That helps you decide, obviously, which way you're going. Okay, now horizontal asymptote, that is when you have your limit as x goes to plus or minus infinity equals an L. So y equals L would be your horizontal. Now the slant asymptote, we're going to talk more about tomorrow, but this is when your top degree is greater than bottom by 1. So example, x cubed over x squared. Now in the past we said, oh, but that must be going to infinity, right? If the top is bigger than the bottom. Now if the top is bigger than the bottom, or greater than the bottom, it does go to infinity. But if it's bigger just by 1, then it actually does a slant. Okay? Now all this stuff is going to occur on rational expressions. So most likely you're going to see a rational expression on an exam, or all asymptotes would be kind of out. And we'd want to know if you know how to do them. Okay, then after you've done all that, the first derivative test. So the biggest part of the second derivative test is finding CVs. And that's when f prime of x equals 0 or does not exist. Okay, the positive and negative signs occur where the curve is rising and falling. And you want to state coordinates of max / min points. Okay, after you've done all that, we want to talk about concavity, and points of inflection. Okay, so when CVs equal, when f double prime of x equals 0 or does not exist. Okay, again, the plus and minus signs indicate where the curve is concave up and concave down. And you want to state coordinates of inflection points. Okay, so now when you're sketching the curve, you want to dot all asymptotes. Okay, you want to plot all points. That's your x-intercepts, your y-intercepts, your points of inflection, your maxes, your mins. Okay, and then complete graph using rising, falling, and concavity. Okay, so that's where I'll be, right? I'll do this, and then it's falling here, right? And then, put where it's concave up, and then it goes to concave down, and then concave up. You want to put all that stuff on the graph, and I highly recommend, obviously, doing your graph in pencil, because you may look at it after and go, ooh, I forgot those 2 points. I ignored this is concave up instead of concave down. And, you know, and again, like this stuff, it can be pretty finicky. You could just do one thing wrong and it messes everything up. So I like to just walk around during the exam, maybe even point you in the right direction, because it's it's tough getting one thing wrong and then it messes up your entire graph. Okay. Do we even want to do this one? Oh yeah, let's do this one. This won't take long. Okay, so we're just going to do 2 questions quick and just kind of see how everything goes together. Okay, so first of all, we'll start with domain. What about domain for this one? X in the reals. Okay, so B, let's do intercepts. And again, I don't know how you do it. I always kind of put a box around it myself, or I highlight it, because all the work to me isn't important at the end. I just need the Reader's Digest information, just the condensed, all that's pertinent information to graph it. And sometimes it gets lost in all the work, so you really want to point it out. Okay, let's do y_int. That's always an easy one. So x equals 0. So this one would be 0, 0. Again, maybe put a box around that. X_int. Okay, so that's when y equals 0. So 0 equals, the first thing we're going to do is take an x out of everybody, and I get 3x cubed minus 10x squared plus 45. Oh yeah. Okay. Okay, now this one has kind of a different thing in it. Just I've talked about this before. But if this is always half of this, like another example, if it was 3x to the 6 minus 10x cubed, right, plus a constant, right, you can do them just like you've always done. What 2 things add to give me negative 10, multiply to give me. Now this one, you want to use your quadratic. So in this case, we're going to go what x squared equals, and it's negative b, so it's negative 10 plus or minus negative 10 squared minus 4 times 3 times 45 all over 2a, which is 3. Okay, now what you'll find that this here, this equals a negative. You cannot take the square root of a negative, therefore x squared does not exist. So there's no x_ints. Well, sorry, I shouldn't say that, no, because we got 1 here. Okay, so we will have 0, 0 is your x_int. But there will not be another x-intercept that comes from a quadratic inside, or 4th degree, which we treated like a quadratic. Okay, so we got y_int, we got x_int. Now let's work with symmetry. So C, symmetry. Okay, so we want to put in negative x. You don't have to do it twice, right? Oh, let's see if it's an even function. Let's see if it's an odd function. You just put f of negative x in and see if it comes out as an even or not. So this would be 3 negative x to the 5 minus 10x, sorry, negative x to the 3 plus 45 times negative x. So this equals negative 3x to the 5 plus 10x cubed minus 45x. Now if I take a negative outside, that would be 3x to the 5 minus 10x cubed plus 45x. So f of negative x does equal negative f of x. Therefore, it is an odd function. So symmetrical about origin. And again, maybe let's put a box around that because I do want to know that when I'm writing, making my graph. Okay, D, asymptotes. Okay, so vertical, none, right? Now, horizontal, okay, if it's going to infinity, you want to find out if is it going to negative infinity, is it going to positive infinity. So if you do the limit of f of x, oops, limit f of x as x goes to infinity, okay, if you put it into the formula, you will get positive infinity. Now you do limit as x goes to negative infinity. Okay, so if you got positive infinity again, you can understand, oh, they must both be going up at the ends, right? But this one, when you put it in, you get negative infinity. Okay, so I'm getting something that's going like this. Okay, because if I'm going towards infinity, it's going to positive infinity. Okay, so again, I'm going to box that because I should be taking that information in. Okay, so E, we're looking for increases slash decreases and max mins. Okay, this one's not too hard to do. So we would get, what, 15x to the 4 minus 30x squared plus 45. Okay, not that you have to do this, right, but it does sometimes help. We can take out a 15x to the 4 minus 2x squared plus 3. Now, again, this is another scenario where this is half of this. So you can use your normal factoring, or you can just use your quadratic, because we want to find CVs, right? So at this point, we want to find out when we have a slope of 0 somewhere. So let's put it into our quadratic. That's negative 2 plus or minus negative 2 squared minus 4 times 1 times 3 all over 2 times 1. Okay, now this, you'll see again, gives me negative 8. So this is a negative number. Okay, so no CVs. No max min. Okay, but I still can do this test. Now, if you saw what it looked like, or you can kind of look at the evidence already, you'd be going, well, it doesn't make sense to be doing this test. But if you do the test and you're putting in, like say you put 0 here, and you want to put in like a -1, maybe here you want to put in 1, just to see what's going on. So if you put in a -1 to this, because it does square everything, you do get a positive. And if you put 1 in, you get positive. So you're getting a scenario like this. It's always increasing. Now, that kind of actually reminds me that we kind of didn't do the first thing, is what kind of graph should I be looking for? Where is it starting? Starts low. Okay, it's going to do something like this, right? So that's even something I should have done right from the beginning. Okay, so that's done. Let's do which would be, okay, no, they wanted to know F was local max and mins. So this is kind of F, I guess. Is local max and mins, there are no. And then G asks for concavity. And inflection points, okay? So we want to do second derivative, which would be y double prime is 60 x cubed minus 60x. So y double prime, I can take out a 60x, leave me with x squared minus 1, which is 60x, x plus 1, x minus 1. So I have CVs at 0, -1, and 1. Okay, did I label this one? Oh yeah, make sure you're labeling your graphs. So when I'm marking, I know which graph is which. So, okay, I got -1 as an inflection point, maybe, or most likely, 0 and 1. Okay, so test values, if I put in a -2 into this, I would get a negative, and a negative. So that would be a negative. Okay, and if I put in like 0, this would be -0.5. I would get a negative there. I would get a positive and then a negative. That's a positive. If I put in 0.5, I would get positive, positive, negative. So I get a negative. If I was to put in like 2, I'd get positive, positive, positive. Okay. So I need to find all my inflection points. So I've got one at -1. Okay, so f of -1 means put it into your initial equation and I get -38. If I put in 0, I do get 0. And if I put in f of 1, I get 38. And that makes kind of sense since this is symmetrical about the origin. Okay, let's draw this thing up, see what we get. Okay, so I have a y-intercept right here and an x-int. It's the only one. Okay, remember that I have to be going, I got to start here, and I got an end here. Okay, so I'm just going down the list and grabbing everything. So that's domain, we figured out. Y-intercept X, symmetry. Remember that it is, maybe you want it is odd function. Okay, so make sure what's going on in quadrant 1 is the same thing that's going on in quadrant 3. Okay, next, asymptotes, there is none, but here for horizontal, I gotta make sure that I am going to negative infinity, and here I am going. Now all of those, my start and my end, that should make sense, okay? Next, increases and decreases. So I am increasing every single place on here, which makes sense to my starting in 3, ending in 1. Okay, then I got no max and mins. Now my inflection points are at 0. That was 0, 0, so I can write that as an IP. -1 and -38. So whatever my scale is here, -38. Okay, so that's an IP. And then at 38 and 1, I have another IP. Now from all the way, just going to bring this up here, to -1, I am concave down. From -1 to 0, I am concave up. From 0 to 1, I am concave down. And from 1 all the way to infinity, I am concave up. Okay, have I missed any information? Okay, so I got to start in 3. Now from all the way, I'm always going to be increasing. For the all the way to -1, I am going to be going concave down. Then from the inflection point to the x, y end, I'll be going concave up. Okay, and then from inflection point to 1, it says go concave down, and then go concave up. That makes sense? Anything that you're going, whoa, 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 you missed this, why didn't you do this? Yep. There's no max or min because I could not find a slope of 0 anywhere in my first derivative. So if I can't find a first derivative that equals 0, then there's no max or mins. Yep. You should look for horizontal ones, but sometimes if it's asked for them, I want you to put down, in this case it was D, asymptotes, vertical, none, right, horizontal, just to show me that you, because we want to have the same instructions for every one of them, right, and just to build consistency in. Okay, so this one here, let's try and speed it up a bit, so we're just getting right to getting all the evidence and then graphing. So A, domain. So x cannot equal -4. So my domain would be -infinity. I know you said it. I was repeating it. When you want me to say it like over the airwaves, that you did such a good job, McLean. I'm proud of you. Okay, so this is maybe something that you just want to, right, put a box around that. Most times the rational expression keeps reminding you that that's not going to be a good spot. Okay, let's go to intercepts. Okay, so I am looking for y int. That's when x equals 0. Right, so that would equal -1. So y int 0, -1. Again, put a box around that. X int, so when does this thing equal 0? Okay, you should be able to just look at it, tell when this would equal 0. When x equals 4, right? Okay, symmetry, C, so if I put in f of -x, -x minus 4 over -x plus 4. If I took out a negative out of the top, that would be -x plus 4 over -x minus 4. I am not going to get it to look like the initial equation at all, so no symmetry. Okay, D, asymptotes. Okay, so we know we have a vertical asymptote at -4, but we want to go from -4 on the left and the right to be able to establish how is the graph behaving around that asymptote. So let's do limit as x goes to -4 from the left. Again, what's the test value? So I have my bearings. -4.0001. Okay, so that would give me a negative up top over a, what would be in the bottom? Small negative. So negative over a small negative would be positive infinity. Okay, if I do limit as x approaches -4 from the right, okay, again, I'd be doing a test value of -3.9999. So I'm still going to be negative up top over a small positive on the bottom, which would equal negative infinity. Okay, so this is -4. As I'm coming from the left, I will be going like this. And as I am coming from the right, I'll be going like that. And that's a pretty big piece of information. That's kind of keeping me from thinking that it is coming together like this, right? Okay, horizontal. Remember, that's where you put infinity in. As x approaches infinity, what would this approach? Right, we got x over x, right? So this would approach 1. So y equals 1 is a horizontal asymptote. Again, Okay, E. So we want intervals of increase or decrease. Okay, so f prime x. Now this you do or do not have to. You can use the quotient law, whatever, but it is 8 over x plus 4 squared. Okay, so I'm not going to go and do the first derivative with you because I don't know how to do that. We just got to get moving on with just graphing here. Okay, so remember that we have a CV at, critical value at what? -4, okay, because that's where it's undefined. So here's my f prime x. I'm putting -4 there, but I'm going to draw an asymptote because then I will not be looking for a max or min there. If I don't draw that dotted line, sometimes I forget it's a dotted line. I spend a bunch of time looking for it, right? And that's time obviously I could be using somewhere else. So if I put in -5 into here, I will get a positive. And if I put in like 5, I would get a positive. So I am increasing. Okay, so sometimes if I ask you for what would be the intervals of increase, we would say increasing -infinity to -4, union -4 to infinity. Okay, F asks for max and mins. Okay, since my CV is undefined, there's no max or mins there. Okay, G, we're looking for concave down or concave up, and IPs. So y double prime is -16 over x plus 4 cubed. Our critical value is where? -4. Okay, so f double prime x, -4. So if I put in -5, I will be getting a negative over a negative, which is a positive, which is a happy face. If I am doing, say, 5, I don't even know why I'm doing 5. I should just do 0, but okay. If I put in 0, I will get a negative over a positive. It gives me a negative. It's concave down. So, and then since -4 does not exist, no IP or IPs. Okay, now we just draw it. Fun part. Okay, so starting right from the beginning, domain x cannot equal -4. Okay, intercepts. I have an intercept at 0, -1, a y-intercept of 0, -1. So that's y int. And an x-intercept at 4, 0. So it'll be about there. If I look at my -4, that'd be my x-int. Yeah, we got a vertical there. We already put it in. We got a horizontal asymptote at 1. Intervals of increase and decrease. According to this, I am increasing everywhere. Okay, there are no max mins. Okay, and then I'm looking for, next is where I am concave up and down. Okay, so I'm concave up all the way to -4. So concave up, -4 on, I am concave down. Okay, did I miss anything? Okay, again, now the big thing is not to assume anything that we don't know. Okay, so we know that we cannot go through here anywhere. Because if we could, we would have another x-intercept would have shown up when we did that. Okay? So the question would be, how are we going to be, oh yeah, I guess one thing I have not put on here is this stuff. What's going on my asymptote. So that's valuable. Because I'm going this way here and this way. So where would we be putting the first part of our graph? It's got to be above the horizontal asymptote, right? Now, that's the best we're going to do there. And then the other one, so I'm concave up, I'm increasing. This has to now be concave down. You can try putting, see if you can get the answer 1, like, so go solve for 1, because it says it goes through y equals 1, right? So then if I put 1 and I can solve for x, that would be the point it goes through. I am definitely not going to get that. Now when the horizontal asymptote is 0 and you found x-intercepts, that's a really good indicator to know you're going through. Okay, but I'm not going to get caught up on it. Okay, does this make sense? Okay, so we're doing page 240, 2, 4, 6, 8. Okay, these are obviously a lot of work. So you got to find that balance between doing enough to get practice and too much, right? Or you're not going to do them at all. Okay, tomorrow we're going to do slant asymptotes, and then we've done the unit.